What if the object now tracing an elliptical arc around the Sun is not just drifting on momentum alone, but carrying enough nuclear fuel to power an entire city for 10,000 years? What if the propulsion system aboard 3I Atlas is not speculation and not the fantasy of a Harvard professor, but a real phenomenon confirmed by gamma-ray data from Fermi? Set your doubts aside for a moment. Forget the dismissals from space agencies. And for the next few minutes, let the cold objective numbers tell you a story that many people are still not ready to face. 3I Atlas mattered from the very beginning because astronomers did not identify it as unusual after months of debate, but almost as soon as they understood the shape and speed of its path. What made this object different was not its brightness and not the size of its tail, but the fact that its trajectory pointed to a place far beyond the solar system. That single detail changed everything, because once a body is shown to come from interstellar space, every image, every spectrum, and every motion becomes more valuable than usual. Most comets we know are long-term residents of our cosmic neighborhood, even when they spend huge stretches of time far from the Sun. They may come from the Kuiper Belt or the Oort cloud, and they may take centuries or even much longer to return, but they still belong to the same gravitational family. 3I Atlas did not fit that pattern. NASA explains that astronomers classified it as interstellar because of its high velocity and the hyperbolic shape of its orbit, which means its path does not form a closed loop around the Sun. When researchers traced that orbit backward, the result did not lead to some distant region of our own system. It led outward, beyond it. That is the first reason this object deserves attention, because a hyperbolic orbit is not just a technical label for specialists. It is the clue that tells us this traveler was not born here. In simple terms, 3I Atlas is not circling the Sun the way a normal comet does. It is passing through. It entered our system from interstellar space, crossed through the inner region, and will continue on its way out after this encounter is over. NASA describes it as only the third known object from outside our solar system ever discovered passing through our celestial neighborhood, which immediately places it in one of the rarest categories in modern astronomy. That number matters more than it may seem at first. This is not the 100th case that scientists can compare against a huge library of similar objects. It is not even the 10th. Before 3I Atlas, humanity had only confirmed two such visitors, 1I Oumuamua in 2017 and 2I Borisov in 2019. So when a third object appears, astronomers are not just observing another comet. They are adding one more piece to a sample size that is still painfully small. That is why even a modest detail can carry unusual weight, because with so few confirmed interstellar objects, each one helps define the rules for all the others that may be found later. There is also something quietly dramatic about the timing of a discovery like this. An object can spend ages moving through the darkness between stars, then enter our system for one brief passage that humans happen to witness during a short technological window. That is part of what gives 3I Atlas its power as a story. It is not just rare in the statistical sense, it is rare in the human sense, because this may be the only moment in history when our generation gets to watch this particular visitor at all. NASA notes that the comet will soon leave the solar system and never return, which means every observation gathered now belongs to a limited and unrepeatable opportunity. What makes this even more striking is that 3I Atlas was not discovered because it came especially close to Earth or posed a direct danger. In fact, NASA states that it does not threaten our planet. Its importance comes from a very different kind of tension. It matters because it is foreign. It matters because it is fleeting. And it matters because the moment scientists realized where it came from, it stopped being just another point of light and became a messenger from a place no spacecraft of ours has ever reached. That is why the opening chapter of the 3I Atlas story is not really about controversy yet. It is about identity. Before anyone argued over strange chemistry, unusual jets, or bold interpretations, the first major fact was already astonishing enough. We were looking at an object that did not belong to the solar system at all. And once that truth was established, the value of every future measurement rose instantly, because scientists were no longer studying a familiar kind of comet under unfamiliar conditions. They were studying material that may have formed around another star. The rarest objects are not always the most dangerous, but they are often the ones that teach us the most. 3I Atlas earned that status before the biggest debates even began. It did so simply by arriving from a place beyond the map we usually use to explain our own cosmic past. And once astronomers understood that this visitor came from outside the solar system, the next mystery became even harder to ignore, because suddenly, one telescope was never going to be enough. 3I Atlas became even more important once astronomers realized it would not be studied by one telescope alone, because the moment its identity was clear, a much larger observing effort began. What made this stage so unusual was not a lack of information, but the opposite. Data started arriving from many directions at once, which meant this object could be tracked, compared, and tested through a far wider scientific lens than most rare discoveries ever receive. One of the most striking details is that 3I Atlas was seen before it was officially recognized. NASA says TESS had already captured the object in May 2025, weeks before Atlas formally discovered it on July 1, 2025 in Chile. That gives the story a strange sense of timing, because this interstellar visitor had already crossed the field of view of a major space telescope before scientists understood what they were looking at. It was there first, and only later did the full meaning of that earlier sighting become clear. After that, the response widened fast. NASA says more than a dozen missions contributed observations of 3I Atlas, including Hubble, Webb, TESS, Swift, Sphere-X, Perseverance, MRO, MAVEN, Europa Clipper, Lucy, Psyche, Parker Solar Probe, Punch, and SOHO. That list matters because these instruments were built for very different goals, yet for a short time, they all became part of one larger effort to understand the same object. Instead of a single dramatic discovery, the story of 3I Atlas became a layered investigation built from many viewpoints across space. ESA moved quickly as well, and that added another level of confidence to the picture. ESA says telescopes in Hawaii, Chile, and Australia were rapidly used to monitor the object after it was flagged, which meant the tracking effort was not limited to one agency or one observing team. That matters because once many groups in different places begin following the same visitor, even small details start to carry more weight. The mystery around 3I Atlas grew, not because no one could see it clearly, but because more and more instruments kept adding to the record. That is what changed the mood of the entire story. 3I Atlas was no longer just a rare object passing through the solar system. It had become the center of a global observing effort, and every new image pushed the investigation one step further. And once that network had gathered enough data, the next layer became far more revealing, because scientists could finally begin asking not just where this visitor came from, but what it was actually made of. The most revealing shift in the 3I Atlas story came when scientists stopped asking only where it came from and started asking what it was made of, because chemistry can preserve the memory of an object's birthplace long after motion only tells us where it has traveled. That is why this part of the investigation matters so much. A comet's gases, dust, and ices are not random decoration around a bright nucleus. They are clues left by temperature, pressure, and material conditions in the system where that body formed. And in the case of 3I Atlas, those clues began to suggest something familiar enough to recognize, but different enough to feel unsettling. One of the strongest findings is that 3I Atlas does not seem to match the usual chemical balance people expect from a typical comet in our own solar system. NASA says the object was studied with a combination of observations from MAVEN, the James Webb Space Telescope, and Sphere-X, and that these data revealed unusual ratios in the production of water, carbon dioxide, and carbon monoxide. That does not mean the comet is made of impossible materials. It means the mix is different enough to matter, because scientists can use those differences to compare 3I Atlas with comets born much closer to our Sun. Instead of looking alien in a cinematic way, it looks foreign in a scientific one, and that may be even more important. The detail that stands out most is the heavy role of carbon dioxide. NASA, ESA, and Webb-related releases all point to a coma strongly shaped by carbon dioxide gas, alongside smaller amounts of water, carbon monoxide, carbonyl sulfide, and water ice. That matters because comets in our solar system often draw attention through water-driven activity when they warm up near the Sun, but 3I Atlas appears to tell a more carbon dioxide-rich story. ESA's frequently asked questions on the object explicitly lists carbon dioxide, water, carbon monoxide, carbonyl sulfide, and water ice among the materials released as the comet heated up, while NASA's summaries frame the composition as an opportunity to learn how material from another planetary system may differ from our own. That difference is not just a small footnote for specialists. It changes the tone of the whole object. A comet rich in carbon dioxide can point to formation in a colder environment where such ices were easier to preserve, and that opens a larger window into the chemistry of another system's outer regions. In simple terms, 3I Atlas may be carrying a frozen record of a place built under conditions unlike the ones that shaped many of the comets we know best. When astronomers say this object helps them compare our solar system with others, this is exactly the kind of evidence they mean. The Webb observations helped push that picture further. ESA states that Webb observed 3I Atlas on August 6, 2025 with its near-infrared spectrograph to help reveal the comet's size, physical properties, and chemical composition. That kind of spectroscopy matters because it does not simply show a bright blur in space. It separates light into patterns that let researchers identify specific molecules, which turns a distant smudge into something much more readable. Once that happened, 3I Atlas stopped being just a moving point with a tail and started looking more like a chemical document from another stellar neighborhood. Sphere-X added something equally important because it observed the infrared light from dust, water, organic molecules, and carbon dioxide in the coma during its December 2025 campaign. That gave scientists another angle on the same object and helped confirm that the chemistry was not resting on a single instrument or one isolated interpretation. When multiple missions begin to agree on the same broad picture, the argument becomes harder to dismiss as noise. NASA's Sphere-X team described the comet as containing carbon dioxide, dust, water, and organics, which deepened the sense that 3I Atlas was both recognizably cometary and chemically distinct in a way worth taking seriously. There is another reason this chapter feels so important. The chemistry of 3I Atlas does not scream with one impossible substance that breaks physics. Instead, it unsettles by leaning too far in certain directions. That makes the story more interesting, not less, because real scientific tension often begins there. A completely impossible signal would be easy to challenge. A pattern that still fits inside nature, yet sits far from what feels normal, is much harder to ignore. That is why the object's composition became such a powerful part of the debate. It did not destroy the comet explanation. It made that explanation more nuanced and more demanding. For a general audience, the easiest way to understand this is to imagine two letters written in the same language but with very different accents. 3I Atlas still looks like a comet in broad terms. It has a coma, releases gas, and responds to solar heating, but the balance of what it is releasing and how strongly certain molecules appear makes it sound like it learned its chemistry somewhere else. That is exactly why scientists care so much. They are not only studying a rare visitor, they are hearing the chemical accent of another system through the gases it sheds into space. And once the chemistry began to suggest that 3I Atlas was not just rare, but also strangely distinctive, the story naturally moved into more dangerous territory, because the next step was no longer about what the instruments detected. It was about how some researchers began to interpret those differences, and that is where Avi Loeb pushed the conversation far beyond an unusual comet. The story changed once Avi Loeb entered the debate, because he did not look at 3I Atlas as just a rare interstellar comet and leave it there. He looked at the same object and argued that too many unusual details seemed to be gathering in one place. That became the center of his case. In his view, the issue was not one strange feature by itself, but a pattern formed by many small irregularities that appeared harder to dismiss when seen together. Loeb focused especially on the orbit, the motion, and the visible activity around the object. He pointed to its retrograde path near the ecliptic plane, its reported non-gravitational acceleration, and the jet structures around it as signs that 3I Atlas might deserve a more radical explanation than an ordinary comet. By March 2026, he was publicly referring to a growing list of anomalies and treating them as parts of one larger picture rather than isolated curiosities. What made his argument so powerful was the way he built it. He did not rely on one dramatic signal. He stacked detail upon detail until the possibility of a technological origin began to feel harder for many people to ignore. That approach gave 3I Atlas a new kind of tension, because the object was no longer being discussed only as a scientific target, but also as a possible sign of something far bigger. At the same time, this is where the distinction between observation and interpretation becomes critical. The orbit is real. The unusual features in the data were discussed publicly. But the step from those features to a technological explanation belongs to Loeb's reading of the evidence, not to an official scientific consensus. That difference matters because the next stage of the story was no longer just about what 3I Atlas was doing. It was about how mainstream science would respond when one astronomer pushed the meaning of the data far beyond the cautious language of the institutions. The real tension around 3I Atlas did not grow only because the object was unusual, but because the gap between bold interpretation and official language quickly became part of the story itself. Once Avi Loeb and others began reading deeper meaning into the data, the public was no longer watching only a comet. It was also watching how major scientific institutions chose to speak, how slowly they moved, and how much uncertainty they were willing to show in public. Mainstream science did not respond by declaring 3I Atlas artificial, and it also did not treat every dramatic claim as equally credible. NASA's official pages continued to describe 3I Atlas as a comet from interstellar space, emphasized that it poses no threat to Earth, and framed the object as a rare scientific opportunity rather than a technological mystery. That choice may sound cautious, But in science, cautious language is often the default when evidence is still being tested across many teams and many instruments. The SETI Institute took a similarly careful position, and that matters because SETI is one of the last places you would expect to dismiss a possible technosignature without looking closely. In December 2025, Breakthrough Listen observations summarized by SETI said there was no evidence suggesting that 3I Atlas was anything other than a natural astrophysical object, while also saying that thorough study was still justified because only 3 interstellar objects had ever been confirmed. That balance is important because it shows the mainstream response was not built on mockery or indifference. It was built on a simple rule that extraordinary claims require stronger evidence than an unusual orbit, odd chemistry, or public excitement. At the same time, that very caution was easy for the public to misread. When scientists say there is no evidence yet, many people hear that as evasion. When agencies avoid dramatic language, some audiences see a cover-up where researchers see professional restraint. And when data are still being checked, silence during the review process can feel louder than any announcement. That is one reason the 3I Atlas debate spread so fast beyond astronomy circles, because the style of scientific communication itself became part of the mystery for outsiders watching from a distance. The IAU clearly saw that problem growing, and its response shows how serious the communication issue had become. In February 2026, the International Astronomical Union launched a global effort specifically aimed at spreading accurate information about 3I Atlas while limiting the impact of sensational rumors and false claims circulating online. That step is striking because the IAU does not normally need to run a misinformation campaign around an ordinary comet story. The fact that it did so here tells us that 3I Atlas had already become more than a scientific event. It had become an information battle. This is where the whole picture becomes more mature and more interesting. The conflict was never just science versus imagination. It was also speed versus method. Public speculation moves in hours, social media narratives move in minutes, but institutional science moves only after cross-checks, review, and replication. That slower rhythm can look weak in a viral moment, yet it is also the reason scientific consensus usually survives longer than the headlines built against it. Seen from that angle, the phrase "NASA is silent" becomes less useful than it first sounds. NASA was not presenting 3I Atlas as an alien probe, but it was not ignoring the object either. It was publishing official summaries, releasing data, highlighting observations from multiple missions, and treating the visitor as a major scientific target. The silence many people felt was not the absence of attention. It was the absence of the dramatic conclusion they wanted institutions to confirm before the evidence had earned it. That is what makes this chapter so important in the larger story. 3I Atlas did not only test telescopes, models, and orbital calculations. It also tested how modern science explains uncertainty in a culture that is hungry for certainty, especially when the subject touches something as emotionally powerful as the possibility of intelligence beyond Earth. And once that pressure reached its peak, the most important meaning of 3I Atlas started to shift again, because the object was becoming valuable not only for what it might be, but for what it was forcing science to become. The deepest importance of 3I Atlas may not be whether it proves an extraordinary theory, but what it is already changing in the way science studies rare objects from beyond the solar system. Even if it is fully natural, it has still forced astronomers to observe an interstellar visitor with a level of coordination and reach that did not exist for the first such discoveries. That alone makes it more than a passing comet story. NASA has stressed that the data gathered from 3I Atlas will remain valuable long after the object is gone, because researchers will keep using those observations to study its structure, composition, and behavior. That means this encounter is not ending when the comet leaves. It is becoming part of a lasting scientific record that future teams can revisit and test again. This is why 3I Atlas matters beyond the current debate. It is helping scientists compare our solar system with material shaped around another star, and it is also showing how modern astronomy can respond when a rare visitor appears. ESA's fast follow-up work and NASA's multi-mission campaign both show that astronomy is moving toward a more connected way of studying the sky, where many instruments can build one shared investigation. There is also a larger future taking shape behind this story. Rubin Observatory has said that astronomy is moving toward an era when many more interstellar objects may be detected, which means 3I Atlas may one day be remembered not only as a remarkable visitor, but as an early example of how science learned to handle a whole new class of targets. So even if the boldest theories fade, the real legacy of 3I Atlas will remain. It has widened the tools, habits, and expectations of modern astronomy. And once the argument over what this object is begins to cool, one final truth becomes harder to ignore, because the biggest mystery may not be hidden inside the visitor itself, but inside the way humans react when the universe sends us something we do not yet fully understand. In the end, the biggest mystery of 3I Atlas may not be the object itself, but the way we respond to something we do not fully understand. Some people see a rare comet, while others see the outline of a much larger possibility. Between those two views is the real meaning of this story. Even if 3I Atlas turns out to be completely natural, it has still forced science to look harder, move faster, and question more than before. That alone makes it important, because sometimes the most powerful discovery is not finding proof of the impossible. It is realizing that the universe is still far stranger than our current explanations.